Claude Code Practical Guide, Debugging, Test Automation, and CUDA Environment Setup with Opus 4.6. Introduction. Claude Code is a CLI, command line interface, tool provided by Anthropic that allows you to directly invoke Claude Opus 4.6 from your terminal to perform coding, debugging, and environment setup. Its distinct feature is that it is editor-independent and can be directly integrated into your existing workflows. In this article, we explain the following practical use cases using Claude Code. Project control via Claude.md for cost and quality management. A debugging case study of a Flask app. Automatic generation of pytest test code. Assistance in setting up an RTX 5090 plus CUDA 13.1 environment. CI/CD automation with GitHub Actions. Chapter 1, Project Control with Claude.md. Claude Code automatically reads in the project root to control the AI's behavior. This eliminates the need to provide instructions in every prompt, allowing you to obtain consistent outputs across the entire team. Example of Claude.md. This suppresses redundant explanations and unnecessary decorations, allowing you to get practical outputs while reducing token consumption. Chapter 2, Debugging Case Study, Flask App Value Error. Situation. A 500 error occurred during a specific request at the endpoint of the User Management API. The log records. Code containing the bug. Resolution with Claude Code. Pass the error log and code to Claude Code. Claude Code's observation: it runs against the field in the request body, but the body's ID is not needed for the update process. Only the URL parameter should be used. After the fix. Chapter 3, Automatic Test Code Generation. Basic Test Generation. Target Code, Calculator.py. Instruction to Claude Code. Generated Test. Mocking external dependencies. For testing functions that call APIs, you can also generate mock code using unitest.mock. Chapter 4, RTX 5090 plus CUDA 13.1 Environment Setup. The most common pitfall when setting up a GPU environment is version consistency among the driver, CUDA, and PyTorch. Pass error messages to Claude Code to identify causes and apply fixes. CUDA Environment Setup on WSL2. In WSL2, you do not install NVIDIA drivers on the Linux side. Windows side drivers are automatically mounted. Only the CUDA toolkit is installed. PyTorch installation and operation check. Follow the installation guide on the official PyTorch website, pytorch.org, to install it using the method that matches your CUDA version. Verification script. For an RTX 5090, it will display approximately 32 GB and SM_120. If an error occurs, you can pass it straight to Claude Code to identify the cause. Chapter 5, CI/CD automation. CI workflow via GitHub Actions. CD workflow to EC2. Conclusion. Key points for utilizing Claude Code plus Opus 4.6. Define project rules with Claude.md to control output quality and cost. Accelerate debugging by passing error logs plus code together. Automate test code generation, covering parameterized tests and mocks. Resolve CUDA/PyTorch version mismatches by passing error messages as they are. Reduce manual labor by generating boilerplates for CI/CD workflows. Because it is an editor-independent CLI tool, you can use the same workflow in any scenario, such as on SSH-connected servers or CI environments.